Good evening, students. Today we will see a topic performance of a two-level memory from the memory unit. So the performance of a two-level memory can be measured in terms of the heat ratio. So heat ratio can be defined as the probability that a virtual address generated by the CPU refers to information currently stored in the faster memory, say M1. So here we are representing M1, a memory which is near to CPU, and another level of memory that is M2, which is far away from CPU. Say M1 stand for we can say as the cache memory and M2 as a main memory. And so references to M1, we can say that hits can be satisfied much more quickly than references to M2. That is known as misses. So every time a CPU looking for a word in M1 level memory and it received from there, then it is known as hit. But if it is not available in M1, then the CPU have to refer to next level of memory, that is M2, and this is known as miss. And it is desirable to make hit ratio as close to 1 as possible, so that most of the time CPU have to refer level 1 memory, that is fastest memory. So heat ratio can be described as the ratio of total number of hits divided by the total number of hit plus total number of miss. So here N1 stand for number of addresses references satisfied by M1 level 1 memory like cache, and N2 is the number of address references satisfied by M2, that is by main memory. So we can say that it is equivalent to total number of hits divided by total number of hits plus misses. This ratio is known as hit ratio, and the quantity 1 minus h is called the miss ratio. This is the hit ratio, that is total number of hits divided by total number of hits plus total number of misses, and the quantity 1 minus h is known as miss ratio. Next, there is a formula to calculate average access time for the CPU. Let TA1 be the access time of M1 and TA2 be the access time of M2 relative to the CPU. So the average access time TA for the CPU to access a word in the two-level memory is given by TA equals to H stands for hit ratio, multiplied by TA1 plus 1 minus H multiplied by TA2. So this is H stands for hit ratio, and 1 minus S is miss ratio. So this is the average access time of CPU to access a word in 2-level memory. That is, if there is CPU, this is CPU, this is a M1 level memory, M1, and this is suppose M2 level memory. Okay, so in 2-level memory, this is the value of average access time. That's it, TA equals to H multiplied by access time of M1 level memory plus 1 minus H into access time of level 2 memory. In most 2-level hierarchies, a request for a word not in the first level M1 causes a block of information containing the requested word to be transferred to M1 from M2. If it is not available in M1, then that word must be transferred from M2 to M1. And in this process, whole block transfer take place in which the requested word is available. And we can say the time TB, this block transfer time, this is the block transfer time, and we are representing as TB, and this is the required for the block transfer. So TA2 can be written as TB block transfer time plus TA1, because word is not available in level 1 memory, so it have to block transfer takes place from M2 to M1, and it takes times TB time. So TA2 will be TB plus TA1. So on substituting value of TA2 equals to TB plus TA1 into last equation, that is in the equation of this one, TA equals to H into TA1 plus 1 minus H TA2. In this equation, when we will substitute value of TA2 equals to this TA2 equals to TB plus TA1, we will get H TA1 plus 1 minus H and TB plus TA1. On solving it, we will get this one, TA equals to TA1 plus 1 minus H TB. Thank you.